Students, hope you are well, and I'm going to continue our lesson 4, and I'm going to cover pages between 100 to 102. I need to explain some basic symbols or basic concepts about equation, chemical equation. If you look at the table, you can find some state symbols S, I, G, AQ, which are belong to solid, liquid, gas, and aqueous solution respectively. So if you have a S symbol in a chemical equation, like here A, okay, there are three examples of a chemical equation. Like here, zinc oxide is S. That means after the equation, you will get a solid state or solid phase of your product. This is can be same for calcium carbonate, which is solid structure, and after the reaction, then you will get another solid structure and gas form of carbon dioxide. For example, water in equation 2, water is L. That means, of course, water is liquid. And AQ, aqueous solution, that means the chemical which is dissolved in the water. Like potassium hydroxide. Okay, potassium hydroxide, KOH, is dissolved in water, so we need to put AQ. These are some symbols, state symbol, which gives you more information when you are when you look at the chemical reactions. You can get some more information from state symbols. Okay, this slide shows you ionic equations. Actually, when you put any chemical in water, which is AQ, okay, as I explained, AQ, so they can be separated into ionic form. Okay, for example, here it's a salt, and ACl is a salt, and AgNO3, it's another part of your reaction which is dissolved in water. So after a while, after stirring them to the water, they will separate it. Okay, they will separate it to the ionic form, because there is a water, and they can be separated from molecular form to the ionic form. So through the ionic equation, we can actually cross. We can cross, and we can remove some of these ionic form, because they are not participating in the main reaction. Okay, I put here in some type of reaction only a few ions react, and the other ions are not participated, and spectator ions can be crossed out, can be removed, and the equation can be simplified. The result is essential ionic equation. So we have chemical equation here between these two chemicals, and then you will get some products, and you can convert the molecular form of the chemical to ionic form. Okay, for example, from the first one, which is salt. Okay, is a sodium chloride, can be separated to the sodium ion, cation, and the chloride, which is an ion. Okay, this is based on your knowledge, which you studied from the previous session. And also Ag Silver can be separated from the nitrate, which is a positive, okay, because it's a cation and it's a metal. So if you convert all the molecular form to the ionic form, like as you can see the second equation, then you can see that some of these like sodium is not they are not participated in the reaction. Okay, the reaction means you will get the product of the silver Ag chloride here. So this is important, you need to keep it. And from the reactants is only chloride and Ag silver. So these are important, that means they are participating in the equation. The rest can be removed and make it simple net ionic equation. These are some again, I have repeated in this slide ionic equation that include only particles that participate in the reaction that are called net ionic equation. So these are also same as before with another example, and also this slide shows you more cases you can practice on these equations. I put here for more practice. If